So this is similar to the example that we did yesterday, the second example. So I give you the first point, 1 and 2. Oh, I should probably draw the grid first. I draw the grid. Draw that grid. When I don't put numbers on the grid, it just means that every box is 1. So here, my first point is 1 and 2. 1, 2, right here. That's point A. And then what we did yesterday was we said, okay, given 1 point and the slope, I can find my second point. Right, Emmy? Okay. Yes. Okay, so if my slope is 4/5, that means my rise is 4 and my run is 5. So if Amy wants to take the elevator, she's going to take it 1, 2, 3, 4 floors up. And then it's the 5th door to the right. And it brings us to this second point. One mistake that people make is after they go up 4, they put a dot right here. Okay, don't forget you have to get out of the elevator. So it brings us to this second point, and then we could draw our line. But is this the point that we want? Is this the second point that we want? No, because I gave you part of the second point. It's -4 and something. So I don't want this particular point. I want the point on this side. So what can I do? I can either I can either extend that line because I know it connects those 2 points and then it goes the same direction that way. Or as I was saying, you can go up 4/5, or you can also go down 4 and 5 to the left because you know the direction of the line. It's a positive slope, so I know my line goes this way. So if I were to do the opposite end, 1, 2, 3, 4, 1, 2, 3, 4, 5, it brings us to this point right here. What's the coordinate of that point? James, what's the coordinate of this point? So let's pay attention. -4 and -2, right? So right here, see how I gave you part of the coordinate? So K, in this case, equals -2, because this is the point B that I want, not this one. Okay? Second example, same idea. Okay, I have this. Okay, my first point is 1 and 2. Okay, so again, that's point A right there. All right. So my slope is 2. So what's my rise and what's my run in this case? Vincent? Rise is 2, run is 4. Perfect. All right. So remember, when it's an integer, you can always put it over 1 so that you see your rise and you see your run. A lot of time, as I said, people like to go up 2 and then put a dot right here because they don't see the run. Remember, you have to get out of the elevator. So over 1 brings you over to this. Okay. And then I can connect my line, draw my line. This. Oopsie. All right, the more accurate your line, the better. So, because these 2 points are so close, when you extend your line, you might be a little off, and so forth. So, how do I make my line more accurate? Ubi? Because if I was just drawing a line, it would have been like just like this. But if I want to make my line more accurate, what should I do? Claire? Add more points. That's right. So I know my slope is 2 over 1. So I can go from this point up 2 over 1, up 2 over 1. Same thing right here. Down 2 over 1, down 2 over 1. And I can already see, I mean, my line is very off, actually. So because I know it's supposed to be down 2 over 1, so I already see that my line is so off. Okay, let me just erase that. Then we go down 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1. Okay, so my line should be more like this way. And that is why you don't sketch with pen. Right, something like that. Okay, so just like in the first example, I gave you part of the second coordinate, so -4 and something. So 1, 2, 3, 4. So I'm actually looking for this point down here. So if I continue this pattern, what would this coordinate be? What would this point B be? It would, Claire, -4 and -8. Okay. So this, I purposely made it so that it's off the grid. But if you follow the pattern, your slope is 2. So it's up 2 and 1 to the right, or down 2, 1 to the left. So if you follow this pattern, you should be able to get to -4, -8. Okay. I want you guys to recognize the pattern. Okay. Next. Right here. Okay. Okay. So first point is 1 and 2. So that's point A right there. Okay. It has a slope of 0. What does that mean again? We talked about it at the beginning of class, Justin? No? Okay. Derek? Horizontal line. So basically, I'm just drawing a horizontal line. I don't need any other points. I can already draw my line because m equals 0 is a horizontal line. Okay. I can still find point B on this red line. Okay, where is point B? Claire? Vincent? -4 and 2. I know that all my points are on this red line. If I give you part of the coordinate, that means the point is at -4 and where? At 2, because it's a horizontal line. So in this case, k equals 2. Okay, and then this next one is tricky. Okay, 1 and 2, that's my point A. Okay, undefined slope. What would my line look like in an undefined slope? Vertical, right? So I know my line looks something like this. Okay, now where's point B? There is no point B because I told you part of the coordinate for point B is -4 and something, which is like somewhere over here. Okay, but my line is over here on the positive side. So will my line ever go through point B? No. So point B doesn't exist, or K does not exist. Okay, there's no such value. Okay. So this is a tricky question. Any questions so far? So this is kind of like a recap, add-on to what we did yesterday in the second example. Okay, so let's do two word problems together, and then and that's it. It's just these two last examples on page 6. Speed. Sarah is on the soccer team and runs every morning before school. One day, she ran 5 kilometers in 20 minutes. Calculate the rate of change of Sarah's distance from her starting point. Graph Sarah's distance. This relates to time. And then explain the meaning of the rate of change and how it relates to the graph. Okay, so I'm going to draw the graph. Should I draw L graph or T graph? Why?
It's like a line. It's like you going to a place that's your rate change.
Okay, but why don't I need the negative side? Eric?
You cannot run negative minutes or negative.
Right, okay. Can't go back in time. So we are only dealing with positive numbers, so that's why we have this. Just like on the assignment, a lot of you guys were asking me which one is the independent, which one is the dependent variable. What goes here on the x? Time or distance? Yep.
Time.
Time always goes on the bottom. And then distance on the side. Okay. And then what is this number right here in the corner? Okay. 0, 0. Always 0, 0. So some of you who skipped numbers and put 50 right here, that's half a mark off. Okay. That corner is always 0, 0. Okay. So we could do, for example, like 10 minute, 20 minute, 30 minute, 40 minute, something like that. Minutes. Okay. And then distance, kilometer. We're going to do 5 kilometer, 10 kilometer, 15 kilometers. Okay. We don't know how far she goes. So it says that she can run 5 kilometers in 20 minutes. So that gives us our first point. Okay. And then so after 40 minutes, it means that she ran 10 kilometers. Okay. I can connect those points. Okay. At the beginning of her run, if she doesn't stop, if she doesn't start, she's at 0. So it does go through 0, 0. Oh, by the way, for your assignment, when you guys drew that line of best fit, does it have to go through 0, 0? No. Okay, so keep that in mind. Line of best fit does not have to go through 0, 0. Okay, so now that we have these 2 points, we can calculate our rise over run. Our rise and run. So to go from this point to this point, what was my rise? How much did I go up by? Did I go up by 2 because it's 2 boxes? Uvin? Why? How much did I go up by? 5. Okay, so this, I purposely did like 2 squares right here because I want you guys to know, always, always, always go by the scale, not by the boxes. Okay, people always make this mistake. Okay, from this point to this point, I took the elevator actually 5 floors. Okay, so my rise is 5. My run is how much? What's my run here? Yep, 20. Right, so again, not 4 boxes, but 20. Always go by your scale. Okay, and when you so I can reduce this to 1/4. Okay. Calculate the rate of change of Sarah's distance from her starting point. So 1/4. Graph it as distance relate to time, distance versus time. And then what does this rate of change represent? Okay, so 1 over 4, if I divide it out, is 0.25. What's my unit here? Anyone know what's my unit? It's a word problem. Close. Say that again? Right, kilometers per minute. Kilometer per minute. AKA, what do we call that? What do we call that? Yep. Okay. The title of this speed. Okay, so her rate of change here represents her speed. Every time you have a distance versus time graph, your rate of change is the speed. And you'll see tons and tons and tons of distance time graphs in grade 9, in grade 10. That's basically the most important graph you'll be doing. Okay? Okay. Good. And then this last one right here. The graph shows the volume of gasoline remaining in a car's tank. Calculate the slope of the graph and interpret the slope as a rate of change. Okay? So this first coordinate right here is 0, 65. What does that mean? Yep. Hi. Let me pause the video first. So my initial coordinate right here, 0, 65. What does this mean in the context of the question?
65 liters and 0 kilometers.
65 liters is 0 kilometers. So which means at the beginning, there's 65 liters of fuel in the car. Okay, so this is reading off the graph and making sense of it. Okay, and then at my second point right here, this is 500. And what is that number? 5. Okay, what does this point mean? 505. What do those coordinates represent? Yep. After 500 kilometers, there's 5 liters left. Right, there's only 5 liters of fuel left after driving 500 kilometers. Right, so I'm given these two points right here. So again, if I do my rise over run, I'm calculating the slope, rise over run. Okay, so to go from this point to this point, what's my rise? Right here. This part right here. So how much did I go down by? Vincent? Yeah, 60. And then what's my run? Yep. 500. Okay. So if I divide that out, let me divide 60. 60 divided by 500, 0.12. Okay. Now, something's wrong with my answer right here. Okay, Claire, what did you catch? Negative. So your car doesn't gain more fuel. Alright? Remember, if your rise, you're going down, right? So going down the elevator, it's negative. So it's negative 0.12. What's my unit here? This is a tricky question. What's my unit? Yep.
Gasoline.
Minus 0.12 gasoline. Alright, so liters, okay, part of it. Goofy. Liters per kilometer. Where have we seen units like this before? Chapter 1, unit rates. Okay, so this, your rate of change is just another form of a unit rate. So for every kilometer, it uses 0.12 liters. Okay, so this graph represents the gas consumption. Okay, and that's why it's even titled. Okay. So for these word problems, just remember, and it's rise over run, but if your rise is not rising and it's dropping, then don't forget that negative. Okay? And then, so whenever you're given a graph, you want to do the rise over run. So you're looking at your graph, but you're also, keep in mind, you're looking at the scale, not counting boxes. Okay? And then I think on Tuesday next week, and then next week we'll do more slope with using the coordinates. Okay, so for the weekend, page 7 and 8, and then the challenge questions. If you want to challenge yourself, try the harder questions. It's on page 9.